and take their places on the dais, please. May I request the audience members to kindly switch off their mobile phones or put them on the silent mode. It's going to be a very interesting session. On that note, let me introduce to you the session chairperson, Sri George Kuruvilla, who is an Indian Broadcast Engineering Service officer of 1987 batch. Before joining broadcasting services, he completed M.Tech in Digital Communication Systems from IIT Roorkee in 1988. He had also successfully completed 1-year senior management program in corporate finance from IIM Kolkata in the year 2009. After joining All India Radio in 1989 as assistant director, he was promoted as deputy director and joined as a head of Doordarshan TV station in the state of Sikkim, Gangtok. He was subsequently posted to Doordarshan headquarters, Mandi House, New Delhi in 1997. Between 1997 to 2005, he served in design and maintenance wings of TV transmitters, satellite communication. Later, he worked as superintending engineering Doordarshan Srinagar for 1 year from 2005 to 2006. He was posted to Prasar Bharati Secretariat, New Delhi in February 2007 and was attached to Chief Executive Officer, Prasar Bharati as Officer on Special Duty till May 2012. After serving 23 years in All India Radio and Doordarshan, he joined as a General Manager, Basel, in May 2012. He was responsible for all TV projects, including prestigious TV projects like establishment of Rajya Sabha TV channel and Electronic Media Monitoring Center for recording and monitoring of 600 TV channels for Ministry of Information and Broadcasting. He was selected as full-time director in the board of Basel and served as director O&M from February 2014 to March 2016. Thereafter, he was selected for the position of chairman and managing director, Basel, and took charge from April 2016. Ladies and gentlemen, that is our chairperson for the session, Sri George Kuruvilla. Over to you, sir.
Thank you. Thank you for that introduction. Let's start this session on digital radio broadcasting. And I can sense the excitement that is around here in the house. And we all are looking forward to this great transition that we have to do in looking forward to the digital terrestrial transmission in radio. So let's start this session without wasting much time. Let me introduce Mr. Alexander Zeng. He'll be talking about the opportunities for enhancing the radio business as such. And let me introduce him before he comes on the stage. Since 2000, Alexander Zeng is an MBA, works at the Fraunhofer Institute of Integrated Circuits, Germany, as Vice Group Leader for the work group Broadcast Applications. In 2001, he started as project manager for the Professional Broadcast Encoder, Fraunhofer DRM, DAB Content Server. Since 2002, he is project director of Journaline, an interactive text-based information system for digital radio. In addition, he works in the fields of audio servers, software-defined radio, and transmission protocols. We have seen him from several years in BS as well as in different conferences or seminars that we have been holding. He's an expert in this field, and let us listen to him and try to know what he has on the table today. Mr. Alex.
Thank you very much. So let's get started. We are talking about DRM, Digital FM Band, opportunities for enhancing the radio business. What's in it if we extend the already introduced DRM standard to the local services, the FM band services? First of all, let's have a look at analog FM radio services today. Some of these points apply to India, some of them are more applicable internationally. First of all, there are certain challenges to analog FM radio broadcasting. Above all, there is major competition from other media forms. In some areas, it's considered old style. We're looking at more mobile TV services and other on-demand services. One big concern, particularly for private broadcasters, there's a decline in revenue from advertisement due to perception, not necessarily to reach. And at the same time, in many places, there's a public mandate. You cannot just switch off FM. It's part of the infrastructure for emergency information and maintaining the communication with the listeners. However, apart from all these issues that we need to address, there are certain real benefits for analog FM radio broadcasting. That includes, for those broadcasters in this field, very limited competition. You're competing with a handful, maybe two handful of other local stations. Whereas online, you would be competing with tens of millions of other broadcast services available and very diversified information. In terms of operation cost, it's a flat rate. It's broadcast. You can reach millions of people without a cent extra in a city with a single transmitter infrastructure. So you don't need to pay per listener as you would online. And it is still the major number one listening and entertainment form in the car because it mixes on-time information, news, sports, whatever, with good entertainment. Above all, it's a trusted information source. That's something that cannot be said of social media and other media platforms these days. So broadcasting really is considered trusted media by the listeners. And the question is, how can we capitalize on all these benefits and special pros that FM services have and broadcast radio in general, and how can we overcome the challenges, bring broadcast radio to the next century and millennium? This is where DRM comes in, Digital Radio Mondial, digital FM services. As a quick reminder, I'm sure you've seen that in the past, DRM is the open standard available for all broadcast bands. It has been already rolled out by All India Radio in short and medium wave in this country. But it's equally available in the FM band. You can build receivers, you can put it on air without asking anybody for a license. It's an open ETSI ratified standard, ITU endorsed. The important thing right here is for the FM band, it is fully compatible with the existing spectrum alignment and assignment, as the signal bandwidth is only 96 kilohertz. It's half an FM channel. That's the bandwidth that gives you the capacity to broadcast up to 3 audio programs plus multimedia data applications in a single transmission. In terms of power consumption, depending on your specific coverage needs, but as a rule of thumb, we can save 80 to 90% of the transmission power of analog FM and still achieve the same coverage in digital. If you multiply that with your network infrastructure and the amount of years you're operating this infrastructure, that alone can lead to significant savings. I will show you in a moment. That alone would make sense to upgrade to digital FM. DRM fits in the existing FM band. It is very flexible. It can be placed anywhere where there's a white space in the FM band. And specifically in the case of India, as we know, the TRAI recommendation for the digitization of the FM band says that any license, whether it's digital or analog, should cover 200 kilohertz. And DRM fits perfectly in that scenario, occupying the space in between existing FM stations that at the moment could not be used for other additional other analog FM services. There's even an advantage here, as we could technically also put 2 DRM signals side by side into that space, giving up to 6 audio services, capacity for 6 audio services within one license assignment. That's very appealing, obviously, for broadcasters. Imagine all the services All India Radio has in their FM offerings, how many services and languages you could broadcast in every single location. with such an arrangement. As you can see clearly from the picture, the DRM signal is a standalone. You can place it side by side with the analog FM. However, that is not a recommended mode. Our recommendation is keep it separate, don't interfere with the existing FM services, leave them as they are at full power, full coverage, no upgrade or change required, and add the small power digital services in between through the same combiner infrastructure that the analog services use. Talking about the combiner infrastructure, obviously multiple transmitters, whether analog or digital, today are combined at each FM transmitter site into one antenna feeder line installation, sharing the same location. So far, for analog FM, every broadcaster needs to operate their own FM transmitter. And only the feeder line, the combiners, and the antenna, the site, are shared infrastructure. So that brings down the cost for everybody. What if we could also make the FM transmitter itself a shared infrastructure? And luckily, DRM allows for that. As you can see here, single FM transmitter today can broadcast 2 or even more FM signals side by side. So with a single FM transmitter, you have multiple DRM services on air. They can originate and be operated by one single broadcaster, like in the case of All India Radio. But they could also be a combination of DRM signals coming from different and representing different commercial broadcasters, making the FM transmitter part of the shared infrastructure and bringing down that cost of add-on installations. And we will see a full presentation on that later on from Jens Schröder. There has been plenty of innovation in this field. Just to take away the idea that the white spaces really are too small to add additional services in between, this is an FM spectrum scan from Johannesburg, South Africa. These are all the FM services on air. As you can see, most of the frequencies are used multiple times over. It is a complete nightmare, and obviously there is no way to add any additional analog FM service in the spectrum. However, DRM still can fit in because there are enough gaps. In fact, if you look at the spectrum, there are 16 gaps at least, and that represents, with one DRM service, up to 3 audio programs. That means up to 48 additional radio programs can fit into this spectrum. It has been proven to work reliably. There have been sophisticated tests carried out and not interfering with any of the analog stations surrounding the digital add-on. Talking about simulcast operation in Batam with a regulator and the public broadcaster in Indonesia, we did this trial, a very sophisticated trial, some time back in Band 2, where one existing FM transmitter was converted to simulcast operation to broadcast the ongoing analog FM service in addition to the digital service on the site. As you can see clearly, it works perfectly. The conclusion was it is flawless in terms of operation. You had both the FM signal received clearly and the digital signal. The reason why I said earlier that this kind of simulcast operation from a single transmitter is not our recommendation is because that transmitter, the one single transmitter carrying both analog and digital, would need to operate in linear mode. So that means the maximum output power is strongly reduced compared with running it in saturation for analog only. So by adding a digital sideband, you have to reduce the overall power, and then of course take away some of the power for the digital sidebands, which gives you two options. Either you accept that your analog coverage is shrunken dramatically, which most broadcasters won't accept, or you're ready to replace the equipment with a much stronger FM transmitter equivalent to just get the former analog coverage. Both of these options for us don't seem realistic and really useful. Therefore, in practice, what we recommend is what I showed earlier, adding a small power digital-only transmitter in the white space of the FM spectrum. However, to show you, just to prove to you that simulcast is working, this is the predicted coverage area of the Batam transmitter in Indonesia. This is, the blue one is the prediction. The green one was the actual measurements. And as you can see, even way beyond the predicted coverage area, all the dots were green, meaning perfect reception of the digital signal, even when analog FM was already gone in that simulcast operation. That's the conclusion. No disturbing no disturbance on the neighboring FM stations, including the FM station from the same transmitter. Perfect mobile reception. We had indoor reception in the big city, quite far away from the transmitter side. Definitely a large coverage area for the digital signal. However, how can we take, this is the question for today, how can we take this information that we know is working, that has been proven, how can we take it and apply it for the benefit of the FM broadcasters today? I want to address three elements: listener benefits, financial benefits, and easy migration of your existing analog infrastructure, FM services, and enhance them with a digital component. Listener benefit. First of all, much superior audio quality. Once you are on digital, the quality that the encoder produces in the studio is exactly what is replicated on the receiver side. So as long as you have any signal reception, you have exactly the source audio quality that was created in the studio. It gives the option for more content, up to 3 services in a single transmission, in a single DRM signal, compared with only 1, obviously, in analog. Plus the option for multimedia and data. So that means that I, as a listener, if I have a more niche interest in music or in content, I can be served in the future with digital services from my broadcaster, whereas at the moment, this broadcaster will only serve the tier 1 audience, which makes for a hell of a competition. Advanced media services such as Journaline, Advanced Text allow me to pick up information if I'm somewhere driving on, or I'm somewhere at the beach. I want to have a look at the latest cricket results. I can look it up on my radio sets. I don't need internet. I don't need connectivity. It's all part of the broadcast signal. And we have digital radio aligned with the new mobile services 5G connectivity with 2 ways. First of all, the audio codec used is also now deployed on all the mobile phone platforms, XHE AAC, the most advanced and most efficient MPEG codec for this purpose. That's now available, so immediately on mobile platforms, you can add the DRM functionality as a software add-on. And we have Journaline as a text service, which can link the broadcast information that I can receive on any device with individual services that the broadcaster points me to, that he offers. Be it specific downloads, podcast services, be it pointing to special event pages, purchasing tickets, whatever it is, participating in a phone call-in show, all of that can be enabled through Journaline, linking mobile services and broadcast services very efficiently. And finally, digital radio gives me the integration into emergency warning functionality in the networks of the nation. Looking at it more from a broadcaster's perspective, cost savings. The cost savings of the power alone running your network or a single transmitter, converting it from full analog to full digital, can save you up to 80–90% of power. If you do the calculation, and they give you 3 audio services on that. So if today you're running multiple licenses in each place in the country, if you got a second license, for example, or in the case of All India Radio, if you have a dozen services on air today, each 3 of them can be combined into a single DRM low-power transmission. Instead of running 3 high-power networks, you only need a single low-power DRM network being added and then eventually, hopefully, fully digitized. Using the Journaline Advanced Text service, we have new revenue sources as a broadcaster, very targeted ad placement, because I, as a listener, I select my preferred language, the point of location I'm interested in, the type of information I'm interested in. So at that point, if the broadcaster places an ad or a recommendation, that is very specifically targeted, even though the full content is provided as broadcast to everybody equally. And finally, thanks to the option of having a second and third audio program, we have the benefit of pop-up stations, something to consider as a broadcaster. If there's a big event, a big pop act in a city, or a big festival coming up, you can create a temporary station just for that purpose that gives you great advertisement for your FM infrastructure, for your other channels. It also gives you the opportunity to really generate extra ad revenue through that bus that you create with a pop-up station. I said with the power saving alone, you can save a lot of money, the energy cost to run the transmitters. If we look at this example, just do the math. You have, at the moment, 3 FM services in multiple places, 29 sites in total all over the country. 10 kilowatt analog FM power transmitters. If we were to convert those networks, the 3 networks, into a single digital network covering the same 29 sites and the same number of listeners, digital FM, what does it mean? Assuming a certain power cost, as you can see here, in analog, your annual cost just to power your transmitters would be $1.2 million. Sometimes people are not aware of what it means to run these transmission infrastructures. That is a significant cost investment for every broadcaster. Now, if you look at the analog digital version, digital FM, that's just over $100,000. So that means cost savings by migrating over from analog FM to digital services of over $1 million a year in running your infrastructure, in reaching your audience. And then on top, you get the better services, the extra revenue sources. So what does it all mean if I want to use these benefits? What does it mean for me as a broadcaster? The easy migration to digital FM. Digital radio with DRM has already been adopted in India, so it's not a new standard. The only thing is we're using the same standard also then for the FM band. DRM fits in the existing FM band, and particularly it does not at all tamper with the existing analog services. Phase 3 rollout, everything stays exactly as it is planned. There's no interference, no change of coverage, no change of hardware of the existing analog FM transmitters. And then we just add the efficient DRM transmissions, low power, in between the existing FM services. The existing infrastructure can be reused. We use the same combiner CTI infrastructure that is deployed today to combine multiple analog services together. We just enhance it to make space for an additional digital insert. And finally, for the private broadcasters in particular, no additional competition in contrast to a multiplex solution as it was introduced in Europe and Australia, where suddenly you operate a huge platform and everybody's free to rent space on that platform in theory. You are still in control of your own transmission, whether it's analog or digital. It is a per broadcaster deployment. And finally, the receiver population. There is very luckily already the deployment of DRM services in India, which means that almost all car manufacturers today either already have the models on the road or are ready to put them on the road with DRM built-in, DRM receivers at no extra cost. And as NXP is demonstrating at the booth over there, 49 and 61 in the EXPO, I welcome you there to visit. With a simple software upgrade, all these receivers technically could be made DRM, or could support DRM in the FM band, the same way that future deployments will just have it by default. Because there's no additional IP royalty for the standard technology, there is no additional effort really. It's just enabling that feature in software. Phone manufacturers on mobile phones already do support analog FM. Luckily, thanks to the design of DRM of only 96 kilohertz, we can add that without any hardware changes to existing phone platforms that do support the analog FM today. All that is required is a software update by the platform operator, the platform designer for that phone, to give access to the FM front-end chip on a low level. The rest of the implementation, the actual application that you install to make DRM work on that phone, is already in existence. You can see it again with an external add-on dongle replacing the internal at the booth of DRM. It's working, it's all there. And I can tell you that the cell phone manufacturers told us they are ready to support digital FM in future in addition to analog FM once the decision is finalized in the country. Because it is simply software update, no additional hardware or design required. And finally, all the DRM radios that we saw come out at the booth, all the new models from Starwaves, from Gospel, from Intot, from all these suppliers. Avion is working on new models. All of them are ready for the FM band as well. So you have it as a default feature with the coming population of receivers based on the announcements that we heard 2 days ago from All India Radio about the public information campaign to popularize the AM services. This is all good news. basically telling you the receiver market is ready. Those receivers that I mentioned are then fully ready and prepared for the Indian market because they do both support digital radio DRM in the FM band and in addition the existing ongoing services for all-India radio for the national network in medium and shortwave. Both of that is covered in these receivers. These are truly ready receivers for India. Thanks a lot. If you want to learn more, have a look at the DRM handbook. It's a free download from drm.org. And get in contact with us if you have any questions. Apply to the newsletter. You can request the newsletter on a monthly basis with all the latest updates of what's going on with the DRM rollout in this country. Thank you so much.
Thank you, Alex. Please give a big hand to him. So our next presenter is Mr. Ashraf Al-Dinari, Senior Vice President of Radio Technology Solutions at EXPO Corporation. So I'll just read out his profile. Yeah, carry on. You can take up the stage. Ashraf Al-Dinari is a Senior Vice President at EXPO Corporation, previously IBQT Digital Corporation. He oversees the HD radio engineering teams, manages the certification and quality control processes, and also represents HD radio technology standards at ITU and international regulatory discussions. Ashraf earns BS and MS degree in electrical engineering, concentrating on communication and signal processing technology. He has spent over 20 years working on digital radio programs and has earned several patents on innovative digital radio solutions. Prior to his work on digital broadcasting, Ashraf developed science instruments in support of space research programs and launched solutions on several satellites. Mr. Al-Dinari has generated 5 patents on innovative technology and published 20 papers and technology presentation on his work. Mr. Ashraf, the floor is yours. Yeah.
Thank you very much. Good morning, everyone. I'm pleased to be here. I've attended BEX several times, and it's always a pleasure to come in front of the audience and speak about what's very passionate to me, which is digital radio, as well as all of the other guests up here on the table. I represent the HD radio system, which is a digital radio technology used in several countries around the world. And I'm here to talk to you today about some of the value that digital radio can create. And not only, it's not a vision of what the future might be. What I'm going to present to you today is a vision of what is actually happening with digital radio implementations using HD radio around the world. So I don't know if people realize that yesterday was World Radio Day. Do you remember that? Did you know that? Yeah, yeah. Congratulations for broadcasters. Not only that, this is the 100th anniversary of commercial broadcasting across the world. So, you know, here we are talking about radio still after 100 years. But let's look at the history of radio broadcasting, right? So things started out late 1800s, mid to late 1800s, as technology was developed to send information across frequency waves. And that resulted in the first commercial broadcasting in the 1920s. At that point, you know, there was a big spark of innovation, and once the commercialization started, then people started to use it. Westinghouse in the United States opened or started the first commercial broadcasting on KDKA, and they were trying to figure out, how can I use this technology? What is the purpose of it? And really, if you look back at what they did 100 years ago, it's very similar to what we're doing today with radio. Musical artists, news reports, political and election, sporting events. But most importantly, how do we make money on radio? It's through advertising. So that model has been in place for 100 years. But as our, so advertising has been not only the important factor of radio, but how do you advertise yourself on radio and get people to pay attention to your message? So as our esteemed guest, Alex, had mentioned, that there's now a lot of competition. With analog broadcasting, it was like you were competing with other radio stations. It was kind of a very simple strategy. You know what you had to do to compete with radio stations. in your market and get them to focus, get your listeners to focus on you. But then around, the turn of this century, right, early 2000s, things started to change. The dynamic was different. We started to see competing radio stations, content coming from other sources, whether it was MP3 players or smartphones, and the strategy became a little bit more challenging in terms of how do I keep my station relevant, how do I keep the business opportunity going. And then now, with the plethora of devices, of smartphones, cloud-based streaming, internet radio, podcasts, we're playing chess in 3D. It's a very complex process. But radio still has another 100 years to go, and we're here to talk about that. So speaking from the US perspective, radio is still a very vibrant market around the world, and this is what we're seeing as well. Given all of the technologies that are available, and all the content sources that people have, radio still represents, in the US, the largest medium for information. And that is true that we see that across other markets as well. In America, we have over 255 million listeners listening to radio each week. That's 92% of the listening population. They are still engaging, maybe not as much time as they used to in the past, but they're still engaging with radio. And it's about 73 minutes a day. But with all of the content, radio is still very important. The challenge is, how do we keep up with the other digital media? How do we make radio entertaining? How do we make it attractive, given all of the other content sources that people have? So I'm going to talk to you today a little bit more about the HD radio system. HD radio is a digital broadcasting solution that is rolling out in many markets across the world. We provide our digital technology in the AM and FM operating bands. And as you see, we have operations, commercial transmissions in many markets across North America, some starting in Asia, Africa, and Europe, and there's also a lot of interest as well. In fact, right now, we are doing a trial of our HD radio FM system here in Delhi on 100.5 megahertz. We have a small transmission site that we've coordinated with AIR to demonstrate and highlight the capabilities of the technology, and we are actually demonstrating reception on commercial receivers in our booth here at BES. So after this presentation, I invite you to come by booth 53 to see the HD radio operations, and as well at Nautel, we will be having a technical discussion about the solution. But just to give you a little bit of an overview of what we have, very similar to the other digital technologies, we provide information across a series of digital subcarriers that can be integrated into the broadcast spectrum. We do ours a little differently than the DRM solution, but we provide what's called the simulcast. You can have analog and digital operating on the same transmitter in an efficient way because we have developed technology to make that transmitter much more efficient. And with that, we avoid additional operating costs of new transmitters as well as other combiner services. And with our digital channels, we are providing very similar program and content information. We may call it different names, but we have high quality sound because of the compressed audio. We have program information telling you what's available on the song. We have multicasting, which we call HD2, HD3, HD4. So we can have currently up to 4 audio programs. And as we move forward to an all-digital future where the analog may be turned off, then we can add more digital carriers and provide up to 15 audio programs in that same spectrum. We have artist experience, which allows the transmitter to send pictures, multimedia graphics along with the audio service, and as well emergency alerting, which is for public safety applications, synchronizing CAP messages over the air into the receiver for wake-up functionality. But how do you use digital radio, right? So this is actually based on true implementations that we have today. Right now, over 2,400 radio stations across the world are broadcasting this technology, and they are making use of the technology in a way to reach out to their customers. So as a broadcaster, when someone is tuning the band, they're listening to your analog station, and maybe they're not so excited about the programming at that time. So what do? They tune to another frequency, maybe to your competitor. The benefit of digital broadcasting, in a digital world, if they're tuning to your analog station, now it's an HD station. And with that, we have the multicast options so that they can now find additional programming that you're providing. And that programming can expand based on your archives or your audience in a way that you're not sharing your audience with the competition, but you're actually sharing it with yourself and providing them more reason to continue to listen. What we've seen across the world with different countries that have implemented their digital radio solutions, such as the US, radio has been able to maintain their audience share and actually increase revenue, right? So we're seeing revenue increases across the United States for broadcasting after the digital radio adoption. Similar, we find within the UK, where they have adopted a different radio standard. They have maintained maybe their entire market reach, along with increasing revenues as well as Australia, where other digital technologies are implemented. We see similar kind of story. So there's something about when a market starts adopting digital, they're taking advantage of that digital solution and using that. So we have, let's call it compelling content as a disruptor. Talk about the multicast feature where I have HD 1, 2, 3, 4 channels. We see broadcasters actually using that to reach different segments of their population. As you see in Toronto, the radio station there is offering multicultural services that can highlight different segments of their community with information and content that's important to them. This has been a very interesting approach where stations are now creating these new programming services, and what it has done is allow them to find new advertising opportunities because they're segmenting their market a little bit more. They're fine-tuning their broadcast market to reach a specific population, so the ad network becomes a little bit different. As well, we have sports teams across the US that are actually looking at digital radio and leasing or sponsoring specific HD radio channels with that. And those services allow the radio station to lease part of their bandwidth and create new business opportunities, new models where they can generate additional revenue from the digital radio. Once again, this is happening today. But let's look beyond just the audio content. There's a visual aspect to radio. So your radio, your station in analog shows up on the display. It's not very exciting. However, when you have a digital media format, you can now send pictures synchronized with the audio text information. It becomes a little bit more attractive. How are radio stations using this, visual information? They are actually providing visual advertisement, which now carries a little bit stronger value, but it also has a stronger impact on the listener. What we have found with visual advertising across the US is that the listener actually has better recall of the advertisement. So the advertiser has more of a better service with the digital information. And in fact, some testing has shown how the visual ad has a better impact than just the audio ad. So this is a new way that digital radio can enhance business opportunities. But we can even go beyond that, and we are actually doing it. Digital broadcasting can integrate with other data services and IoT applications. And if you think about it, radio is a wireless data transmission system, and networks are ubiquitous in major markets. Because of that, We can utilize that digital network, that digital wireless transmission, to send not only music and audio content, but also data services into smart city applications, vehicles, and really support the public use of the airwaves. We have demonstrated this commercially across the automotive platform, where broadcasters are now sending live traffic information, which is being integrated into navigation services and future car applications to provide real-time communication to the car to enhance navigation. And radio stations are benefiting from this because they are leasing their digital radio capacity for these services. Similar type of application that is being developed in the automotive space is sending software updates and telematic updates. And this can be applied as well to the city and infrastructure applications for smart city, utility power management, messaging, signage control, and other types of services. So what we see today is a change in the monetization strategies that radio stations that are actually implementing HD radio system are utilizing. Before, we had the traditional advertising model of selling ad space for an audio ad. With the digital broadcast, they are adding visual advertisement at a higher premium. They are showing new data services that are integrating into vehicles and smart infrastructure, and also addressing channel sponsorships and utilizing their digital capacity for other applications. So I think if we take a step back and we look at what digital radio can offer, right, it creates new value and new opportunity for our radio partners. That's the message or the benefit that digital radio can bring to the broadcast industry. At the same time, the consumer gets a richer experience. They're in tune with your radio station. They have greater connection to their local community, whether it's through the car, through the home receiver, or even on a mobile device, which we also have demonstrating in our booth. You can pick up the digital radio signal across all media platforms, and you can also carry it with you wherever you go. So with that, I thank you for your time.
Thank you, Asher, for this presentation on HD radio. Let's move on, and let me go to Yen, Dr. Young. He is the founder and CEO of RF Mondial in Hanover, Germany. And he's the next presenter. And RF Mondial develops and markets worldwide transmitter, monitoring and receiving technology, as well as services for digital broadcasting. That includes DRM, DAB, HD radio. Yen is responsible for business development, sales, and finance. Before RF Mondials, and Yen gained experience in project management and system engineering in the field of communication, automotive, and medical technology. Yen holds degree in management and electrical engineering from Germany and USA. So the floor is yours.
Thank you, Mr. Chairman. As said, I will discuss approaches on how transmitter infrastructures can be shared in a digital radio environment, especially with DRM technology, and especially concentrating on the DRM in the FM band. So the status in India, you all know, the TRI has published a recommendation regarding the digitization of the FM band, and there's a couple of major points that needs to be addressed in that recommendation. So the introduction of the digital radio services in the existing FM band shall not affect the already operating and licensed analog FM transmissions. That's a clear statement. And in addition, it should provide the most cost-effective service and infrastructure platform for private broadcasters. And in that, the private broadcast should have their control over their own content. And I would like to give some technical implementation approaches that DRM-FM, also called the Mode E of the DRM standard, it was also called DRM Plus. That's all the same, complies with all of the requirements. So wrapping up a little bit the presentation from Alex before, we know the DRM is an open standard. So there's a lot of research institutes, companies, broadcasters, manufacturers, network operators that are in that consortium, and it's not a single company representing that standard. DRM is already applied in India in the AM bands very successfully, and so it's very advantageous for professionals and the consumers. For the professionals, for example, the transmitter operators, they know how to feed the signal to the transmitters. They know how to put their content on the multiplexer, the content server. So that's all the same because it's one and the same standard. In addition, it's an advantage for the consumers because the consumer experience will be the same in the AM or in the FM. DRM, as Alex had said, is a bandwidth of 96 kilohertz. We have rounded here a little bit to 100 kilohertz just for the ease of presentation. So it fits in the existing FM channel raster. It can be 150 kilohertz channel raster. It can be set. It is very spectrum efficient. So each of the 100 kilohertz of bandwidth can give up to 3 sound services plus various multimedia components. And as the latest of the audio codecs is used in the DRM standard, it is very efficient audio coding. As Alex had shown, more than one of the DRM blocks can be transmitted from a single DRM transmitter, and that's a little bit where we are concentrating on in this talk, on the technical implementation. And this is very cost efficient because the costs can be shared between the broadcasters if needed. And the benefit is, in such a scenario, each broadcaster is the owner of its content within this 100 kilohertz. The radiated power can be adaptable to the desired coverage, so it's not directly linked to the FM power of the equivalent audio service. We have done one exercise on how technically, for a private broadcasting scenario, such a digital radio strategy could be implemented. And the application scenario is for the Ambedkar TV tower in Pitampura, northwest of Delhi. That was a joint effort of Radio Frequency System, Fraunhofer, and us, together with our friends from BEX, to really see how DRM could be brought into that scenario. So not only talking about it, but really doing a planning exercise on how to do that. So you can see the 2 antennas are very well located in 195 and 215 meters height. So it's a very nice site that can cover New Delhi. And we can see how we can put digital FM without interrupting the actual FM services there. So the current situation is as follows. We have the current services here, so that is FM1 Radio City, that's FM2 Red FM, and that's FM3 Radio Mirchi. They are currently at operation at the TV tower Pitampura. Then there are interim sites, which are shown here, that's Big FM, Radio 1, and Hit FM. They are currently in 800 kilohertz apart, and that's a separation which is still planned and also assumed that it will change to have the best channel separation for analog FM receivers available. In this scenario, we can then simply add DRM blocks. And such a block is not only one DRM channel, but this is 2. So this is 2 DRM scenarios, adding up to, or one having up to 3 audio plus media services. So one of these blocks get basically 6 audio services plus individual media services. Same to this block here and same to this block here. And from a broadcaster perspective, so Radio City, for example, could own the first block. They could own both blocks if they like. But if they only would like to get the first block, the regulator could say, hey, the second block could be a different broadcaster. And they can provide their complete independent content in terms of an MDI stream, which is in the studio, which is fed to the site, and could then broadcast from the site. So the power of the DRM is then adapted to the desired coverage. That can be the same coverage, but they also could share the power of that transmitter differently. It doesn't have to be 50-50. It could be 60-40, so they could share the cost also not equally, if they like. That would be the scenario from a frequency point of view. And if you now go to the transmitter infrastructure that would be needed to enable that, basically, as said, we would have F private broadcasters, or these might be the existing broadcasters, but basically we would have F sources of information. There would be the content programming, there would be the audio source integration, the audio encoding, and the multimedia services. They will then fed via an IP-based SDL link to the transmitter site. That could be a single link, that could be a redundant link, as the broadcaster would like to have that. And then we would have the wideband DRM FM transmitter. And in this case, it would be 2 DRM modulators, but that does not have to be physical DRM modulators. That can be one box where various or several modulators are simply running in parallel. So this infrastructure would be needed to enhance the TV tower in Delhi for additional DRM services. When we add now this scenario to the block diagram of the tower, you see the white areas, that's the existing infrastructure. So we have the 3 FM programs at 91.1 megahertz, at 93.5, and 98.3. And they feed currently to the combiner modules and then to the transmitting area. When we now add the digital, we will have 3 DRM transmitters, wideband transmitters, so there are 200 kilohertz of bandwidth, 2 DRM blocks, meaning in an overall 6 DRM audio services plus additional multimedia services. And what we need to add is a pre-combiner module, which is needed such that these signals are combined in the existing combiner module. So the only thing that is needed is the DRM transmitter. Of course, we need to add some transmitting power because we want to have more programs, and we need to add the pre-combiner module, and that's it. That this is planning, so that this is practically possible. We have, together with Nautel, we call it extended DRM multiplex. Basically, we have shown it at IBC that a current transmitter, a wideband transmitter, can basically operate in such a scenario. We have implemented that, and it is very flexible. So it could be 1 FM and up to 4 DRM channels, each 100 kilohertz wide, so up to 12 audio programs from that single transmitter, or it can be up to 6 pure digital DRM channels. The implementation we've shown at IBC is a digital Nautel FM transmitter. It could be GV, VS, or NV Lite series, so any of the FM series. Then the DRM signal is independently modulated, as said, could be in one box. And the feed from the broadcaster can come from a content server. And with the advanced crash factor reduction algorithms that Nautel has implemented, it is a very efficient way to do though. So when we just want to add an additional DRM signal, we just need to double the transmitter size, as opposed, because the envelope would stay the same, as opposed when you would like to have 1 transmitter and adding 2 FM signals on that. That just is not a linear case, and it will be a real problem for the FM. So it's not a solution to add just an FM signal on that. And as said, this scenario would allow multiple broadcasts to share a single transmitter in terms of operation costs, but also in terms of installation costs. But they maintain the control over their own broadcasting signal. Technically, this shows like this. This is now a small video. On the left side, we see the user interface of a Nautel transmitter operating at 1 kilowatt. That is a GV5. In this scenario, on the right side, you see a monitoring receiver that basically receives that signal. You see here that you have now 2 blocks. That's exactly the scenario that we've shown for the TV tower in Delhi. So such a transmitter would be needed to be added there. And you can see you have on the left side and on the right side. Now it's tuned to 1 frequency. I was too slow. So there was POP 3 and POP 4 as a program. Now it's tuning to the different frequency. And you can see the content is changed. So you see here now the radio programs are called Fraunhofer and Songs. That's just for demonstration purposes that this is basically possible. You see data services like Journal Line, Slideshow, and Electronic Program Guide. That could be a TPEG, for example, if you would like to have traffic information on that. This scenario is chosen with a 4 QAM approach. If you've seen, the range from DRM is from 36 kilobit per DRM block up to 168 kilobit per DRM block. So that's the choice of the broadcaster, if you, how many programs he would like to have, what robustness he would like to have, how many data services he would like to have. That's complete under the control of each individual broadcaster. A different scenario, that is basically we keep our FM in the middle and we just add 2 DRM blocks on the right side, on the left side, meaning we add an additional 12 audio services plus multimedia services to that. Same scenario, now we have here music and radio as audio programs, still being in a 4 QAM configuration, so a lower bitrate configuration. Now tuning to a different frequency, and we will see that we have a 16 QAM configuration now. So this broadcaster chooses, I want to have a higher bitrate, and will then have the possibility to have either more services on that, or more robustness, or a higher bitrate in its audio. So it's very flexible, and this is in the standard of DRM from the beginning of the mode E, so the DRM FM. Going to the next scenario, that's now a scenario where we add 6 DRM channels on the GV transmitter. And you can see now one broadcaster choosing a 4 QAM constellation with 2 programs. And the second, when we retune, or when we tune to the different frequency, you can see that this broadcaster had chosen a 16 QAM, so a higher bitrate, so he can easily have up to 4 programs. So it was POP 3, POP 4 before, and now it is classic EVF, EWF in use. So that shows that on the one hand, the flexibility of such a scenario, so that can be used for existing transmitter sites, just adding 2, 3, or 4 DRM programs with a precombiner, or for new sites, that could be the complete solution. This shows the transmitter side. So transmitter basically is available. You can go to Nautel or to others and simply buy it. And what is shown here at the booth of the DRM, where the part of NXP is, that's booth 49, you can see that it's also implemented in the NXP receiver chips. So that's most of the chips that are in the cars here in India currently, they're using NXP, so they basically can add that as an option. And that's purely software, and you can see here on the left side, they have a local broadcasting now with 4 DRM blocks available, and that's a live reception here on the right side, where you can see not only a maximum of 3 stations, but there's 5, and when you scroll, you would see that there are overall 12. I'm not quite sure what the scenario is, but that shows that this is not a problem for a DRM reception for the receivers, because in digital you can just put the signals right next to each other, and the adjacent channels, they're just thrown away. So that shows the practicability that this is easily to be implemented. So as a summary, the benefits of the proposed approach is to enhance the existing FM transmitter infrastructures in the words of TRI. So the existing FM infrastructure as well as the analog FM service remain unmodified. Furthermore, the equipment additions for DRM are minor, so it minimizes the cost and the upgrade effort, which achieves TRI's requirement basically that this should be done like that. The planning that we've done here together with Bessel was that the capacity is sufficient to grant 1 DRM block for every existing private FM broadcaster. But that can be planned, so it's planned for 6, but it can be planned for more. So there's no technical limitation. It basically shows the flexibility of DRM. You just add another one to the FM transmitter, and that's it. Yeah, every private broadcaster remains full control of their own DRM transmission as shown, so the configuration can be individually set, which gives the flexibility and the full control of the broadcaster, so he does not have to negotiate with the other broadcaster, hey, what you would like to do. He just has its own content server, MDI stream, and that's it. And the same, of course, we have shown that here for a private browser, but the same is possible for AIR transmitting sites. As you can imagine, there are similar setups, so you can add a digital channel or one or more digital channels, so up to 18 programs, for example, to that site. Yeah, receiver capacity, we have seen that in analog, as you know, you have a planning of 800 kilohertz, so we know that analog receiver selectivity is a big problem to broadcast from one transmitter site very close FM signals. Digital receivers, as we've seen, is for transmitter not a problem, and for consumer or automotive receivers not a problem at all. That's the technology that does it, so that is inherent there. And you're, of course, invited to see the implementation on the ARR booth. That's 41 and 61, so it's in the 49 and 61. That's in the booth area, where you can see all the receiver implementations and also the multiple DRM transmitter local setup. So the implementation has been proven with a so-called extended DRM multiplex, but that's just the brand name from Nautel and us. So that's just, it takes the general standard of DRM. It doesn't modify the standard. It just uses it and implements it as it would be needed for a scenario here in India. And the ability to freely mix and combine analog and multiple signals in adjacent channels can give you additional advantage of individually varying power levels. So you do not need to have the same power level. You're not fixed to the power level of your FM. That can be freely decided by the broadcasters and the regulators, of course. It supports single frequency network. So if in the scenario, maybe you have 3 DRM blocks, but only one of the broadcasters would like to have a nationwide or region-wide SFN, that's not a problem at all. He just chooses a different transmitter site, synchronizes it to the DRM signal, and you can make an SFN of only one of the DRM blocks, not all of them. That is possible. And yeah, of course, as we said, the usage of one transmission site, one antenna, and one transmitter is a huge advantage in terms of cost and, of course, maintenance. So the frequency planners and regulators can, with such an approach, allocate national and regional and local digital radio service, and the implementation with DRM FM is the best and flexible way to do so. Thank you for your
Thank you, Jens. So we have seen 3 presentations, and there is a small video from the receiver side, the company called Gospel. On behalf of Gospel, Mr. Santosh is here, and I would request that you can say a few words and maybe quickly show a video, and thereafter we will go into the question-answer session. I think it will be quite interesting, and you know, the presenters to be talking about and maybe a comparative kind of a thing, and so that we gain much more out of this whole discussion.
Yeah, hi. I am here to represent Mr. Hugh Liu, who is the director for DRM products under Gospel. He could not travel to the current scenario in China. I'll just be running a brief video on his behalf.
Dear friends, good day. My name is Haochun Liu, Director of DRM Products of Gospel. First of all, please allow me to express my warm congratulations to the success of the conference. I'm sorry for being unable to join you because of the ongoing epidemic and the travel restrictions. In my opinion, 2020 is a very important year for India's DRM market. India broadcasters have decided to add more DRM hours, to improve indoor reception conditions, and to improve audio quality and add more attractive programs like cricket commentary to DRM channel to attract more listeners. For DRM, these positive measures are undoubtedly of great significance and analog broadcast in the medium wave, short wave, and FM bands. The high-performance active antenna and built-in rechargeable battery allows users to listen to radio program anywhere they like. Bluetooth music, hands-free calling, and the USB playback function will add more fun to the user. All series of receivers support the emergency broadcast receiver, and they also support extended AAC. audio standard, and Jolly text service. This series of models is the latest effort of Gospel to reduce the cost of ownership of the receiver, and its sales price will be very attractive and competitive. This is Jet16. Some of you may have used it before. Its concrete quality and very good performance have been proven by users around the world. We have recently added Russian and Chinese language support to the firmware to support the recent trials in these two countries. In 2019, India is the fourth largest car market in the world, with more than 30 million passenger cars. In order to meet the demands of in-vehicle reception, we have launched two car-DRM receivers, GL501 and 502. All models support receiving DRM and analog broadcast in measure wave and FM bands, and also support the reception of emergency broadcast. The 501 is designed for the aftermarket, while 502 is for OEM market. Both models have the latest operating system, support for car navigation, music, video playback, Bluetooth hands-free calling, and backup camera. We plan to cooperate with local partners to promote these two products in the Indian automotive market. And we also welcome people who are interested to contact us. The topic of this event is Gospel Receivers end-to-end solution to our needs. We have brought not only consumer radios, but also a new product line that is designed for industrial users. During the course of working with NRPA guys on monitoring DRM program in China, we came up with the idea of designing something new to better serve the demands. That is to continuously monitor and evaluate the broadcast coverage and the service quality on a very large geographic scale. So we are very happy to announce the audio broadcast monitoring platform. The platform is designed for the network operators and regulators. It provides a measure for the professionals to deploy a monitoring network across the country and collect key parameters of reception and evaluate the service quality over a long time span. Receivers are being connected to network and collect reception status information are uploaded to the server. The whole process conforms with DRM RCI standard. We believe the audio broadcast monitoring platform will be a powerful tool for the network operators and the regulators to monitor the coverage status and evaluate the efficiency of the network, and it can be used to further improve the service quality. This is GR83 HF antenna. It's an active monopole receiving only antenna. Frequency ranges from 0.3 to 50 MHz. The performance is still excellent, up to 100 MHz. IP2 and IP3 figure indicates it's immune to the most harsh environment full of strong adjacent interference and man-made noises. The antenna is suitable for fixed or mobile installation and can be used for daily monitoring and service quality evaluation purpose. We want to articulate that we are working hard to ensure we are bringing the latest technology in our products. And these products underscores Gospel's commitment to providing easy access to high quality information at affordable costs. And we believe that both consumer and industry can benefit from it. Don't forget to follow our Facebook page. We will post news and firmware and product video on it. Thank you very much for listening, and I hope to meet you in person in the near future. Thank you very much. Thank you.
You can visit us at booth 49 in the fair. Thanks.
Thank you, Mr. Santosh. Now is the time that we can take few questions from your side. The floor is open, and if you can please raise your hand so that the mic can reach out to you. Yeah, so here is, you can please pass on the mic to.
While going through the presentations of HD radio as well as DRM, there is a discussion on the use of the white space between the FM frequencies. Actually, isolation of 800 kilohertz between the two center frequency of FM provides opportunity for using it. But in one of the experiment with Bessel, and I was also one of the observer, when we installed we tried to use a 400 kilohertz bandwidth, and it was a big interference in the receivers, particularly not having some critically tuned filters. So, and government may also think, because it is luxury, 800 megahertz spacing. So if in case we goes for 400 kilohertz spacing between the two frequencies, the white space opportunities may perhaps not be so luring, and interference may be more. Has there been any study with the 400 kilohertz space, white space and interference due to out of band emission or in the receivers?
Mr. Alex, you would like to answer that? Yeah.
Sure. I assume with the study on 400 kilohertz, you are referring to the analog FM services. Okay, right. This has been proven in the past, particularly with analog receiver Tudor front ends which are very wideband, that if you place the FM services at 400 kilohertz only, there may be some degradation. This is why our proposal is keep the analog FM services at 800 only. These are the high power services. We don't touch them at all. And you use the white space only for the very low power digital services. I was showing that only 10 to 20% of power is required. And with that kind of separation, and if you plan the network according to the parameters that are issued by ITU, the full network planning parameters are there. They are also part of the planning software these days. There will not be any interference at all. That's one of the benefits of having the very low power digital signal in places where an analog signal could not be added. So it's wasted spectrum, which in digital we can recover and make use of.
Yeah. So I think it's a good question. And Yen, you would like to add something, or is done? You know, as we would know that the whole frequency plan today, especially when we look that private FM broadcasters are there in the network as far as the radio is concerned. And generally the separation as we keep is 800 kilohertz, except in some places it may shrink to 600 because of certain frequency allocation. So as he had said, yes. Yeah. What's that?
No, we need to add.
Yeah, okay. Yeah.
Mr. Chairman.
You like to answer that?
Yes.
Okay, please. Yeah.
So the question was addressed to both DRM and HD radio, right? So it is a comparison of how the systems would work. I do think that there is benefit in tight markets where white space is at a minimum, where DRM can be flexible. At the same time, true operating conditions in the US have stations that are separated at 400 kilohertz apart in the same market, operating HD on both of those adjacent stations with no interference. So we do have a proven track record with that. There are several papers that are and reports published within the ITU, as well as tests done by the National Association of Broadcasters that have that data available for your review. So it is possible to do that.
No, right, so we will take the next question. Mr. R.R. Prasad. Yeah.
It is not a question, just wanted to supplement the response to Mr. Dohan's question. Is it on? Yeah, it is on. Yeah, okay. What you said rightly, that experiments were done with for 400 kilohertz spacing, but we did not go for that. Of course, it is feasible, and ITU recommends that, because after 300 and odd kilohertz channel spacing, the protection ratio requirement is almost flat, whether you go 700, 800 or anywhere. Technically, there is no problem, but there is a problem in its implementation, because what had happened that had we decided at that stage, say 2 years or 3 years back, to go for 400 spacing, then we had to change all the combiners, because presently we are using that channel spacing 800 kilohertz. It is a 3-pole combiner. We have to go for 5-pole combiners. That would have been quite costly. And in analog, if you are adding the power, then for 10 kilowatt, you have to add another 10 kilowatt also. The power requirement would have been much higher. In case of digital, it is much lower power requirement, which the present that antenna and feeder cable patch panel can handle. So that's why it was not pursued further. And another point was that why to now change everything for analog when tomorrow digital is going to come?
The question, or rather a suggestion, so I was also a part of the team which has signed DRM as a standard below.
Keep the mic closer. Yeah.
Below 30 megahertz, our HF band. So I have also faced the questions from ministry regarding as much money has been invested, what is the outcome. So we have analog receivers existing. When the FM transition happened, there was a kind of an attachment which people used to buy and attach to their existing receivers and convert it into for FM reception. Thinking business is another angle, is there any possibility for that so that our base can be substantially increased? That is one question.
Who would answer? What he's trying to say is that if we can use the same receiver and can have an attachment, and try to receive the digital signal in the same receiver.
Yeah, maybe Gospel can also say something about that, but there's different ways which exist and which you can see also at the booth. There's an attachment, as Alex has said, to a mobile phone, which you can plug in and then have an app to decode that. So that is an attachment. There's at least one or two models shown which can be added to a car. So you have a car DRM receiver and then add it either as an FM transmitter to the local FM reception or with an auxiliary input added to that thing. And the same, of course, can be put on a desktop box.
Depends on the cost. How much is the cost of your receiver which you have planned for analog FM as well as DRM reception? The cost is a major factor in Indian market. So if that cost is too low, okay, I agree. Then if it is not, then this possibility as an on-time exemption you people should think of. Then only you can increase the consumer base.
Okay, I'm not a manufacturer. What I can point out to you right away is that the Indian car industry has decided, in contrast to other countries, that the DRM feature will be made available to all the car buyers with certain radio models at no cost at all. So that's number one answer. The add-on cost for the consumer in that case is zero. If we look at mobile phones and the FM band in particular, the add-on dongles for the transition would be very low cost. These dongles are available for less than $10. But actually the goal is, once the decision is finalized, that the digital radio functionality DRM will be just part of the mobile phone as analog is today, analog FM. So again, I don't expect any additional cost in that because there is no hardware component, no redesign required for the cell phone manufacturers. If you talk about desktop radios, of course there's always a cost involved. We see very encouraging signs. I mean, we were told that all these brand new models, fully equipped, shown with some of the manufacturers at the booth, they are all below 5,000, and if you go to quantity, they could even reach 2,000. At that point, for desktop radios, it's only a question of quantity.
Okay, anybody else? Okay, all right. I think maybe that can be our last question, or is somebody raring to go for another question?
Yeah. Thank you, Chairman. I'm H. Kumar from CST, Science Technology Promotion. First of all, thank you very much. Give a nice approach to the development activities of in India through the high definition radios. How to be? Recently, I have attended the program of National Science Congress in Bangalore. Our premise says there is a science technology innovation for rural development. In India, 70% population in rural areas. We are facing the problem of climate change. Climate is a consumer right, climate is a human right. How this SD radio, there is a question to Mr. Perry Corporation, how SD radio or a community radio station to access the all technologies to the rural area development for the circular economy as a nation's building, nation's economy.
So if I understand the question correctly, you're asking about maybe a low power community type radio application for digital broadcasting, essentially, right? So the technology is just the modulation portion. How that is implemented in terms of transmitter power and implementation power can go beyond what is done for commercial broadcasting today. So what we have seen in the US market is stations operating some low power applications, especially translator systems, which tend to run to provide coverage increase in maybe a smaller region for enhancement. That same type of technology and application can be provided for localized community radio as well, as long as the regulations allow for that. So it has been done, and it is something that we can provide as well.
Like international conference on recycling and circular for automotive sector. Whatever we imported, more than import, we have already scrap is in India, but not utilized in proper way. So question is, role of media is a radio media or electronic media for nation's building.
Thank you very much. I think your sentiments are well taken by the House. And I think definitely the broadcasters will look into what you're saying. And All India Radio already has a mandate to reach out to the country through radio and also see that rural India is addressed very well. So thank you very much. I think with this, we come to the end of this session. And now I'd leave it for the pleasantries to be done.
Thank you. Thank you very much, sir, for chairing this session, which was on digital radio broadcasting. And if I may please, with your request, kindly trouble you to kindly extend our appreciation in form of mementos. Please, we would like you to present the memento on behalf of BES to Mr. Alexander Zink for his presentation on DRM Digital FM, Opportunities for Enhancing the Radio Business. Thank you very much, Mr. Alexander, for your presentation. Now, if I may request our chairperson for the session to present the memento to Mr. Ashraf El Dinari, who is the Senior Vice President, Digital Platforms, Zephyr Corporation, for his presentation on disruptive technologies and opportunities for digital radio broadcasting. May I now request Mr. Jens from RF Mondial to kindly accept this token of our appreciation with immense gratitude for his presentation, which was Shared DRM Transmitter Infrastructure, a Revolutionary Approach to FM Digitization. And finally, if I may request Mr. Santosh K to accept it, who is from Antriksh Digital on behalf of Gospel. Please kindly accept a small token of our appreciation. Thank you very much all for your such invaluable information and input through your presentation. Last but not the least, please may I request Sri R.K. Singh, who is the former Engineer-in-Chief Akashvani, to please come and present a memento, a token of our appreciation on behalf of BES to our dear chairperson for this session, Sri George Kuruvilla. Thank you very much, George, sir, for your input and your invaluable time to chair this session. With that, we conclude the second session for the day, which was digital radio broadcasting. We're going to go for a break and assemble again, and I'll see you here again at 2:30. Please enjoy the lunch, which is being served now. And I'm going to see you again at about 2:30 for our third session, which is monetization of content on broadcasting platforms. This particular session will be chaired by Mr. Sunil, who is Additional Director General, Prasar Bharati, and would be co-chaired by Rupa Rathore Gaur, retired Head of Sales, Prasar Bharati for Doordarshan and All India Radio. See you at 2:30 and enjoy your lunch. With the last session for today. This will be yet another interesting session which will be chaired by Mr. Sunil, Additional Director General, Prasar Bharati, and Rupa Rathore Gaur, Head of Sales, Prasar Bharati for Doordarshan and All India Radio. May I please request the audience members who are present in the hall to kindly come a little forward and please occupy these vacant seats here. I request everyone who's seated right at the back to kindly come and grace these vacant seats here, please. And if I may also request the audience members to put their mobile phones either on the silent mode or, if possible, can turn them off. So let's start with the third and the final session for the day, which is monetization of content on broadcasting platforms. And may I please request the session chairpersons to kindly come and take the seats on the dais along with the panelists and the speakers who would be presenting in this session today. We are joined by Ms. Anita Nair, Shri Sanjay Dua, Rohit Upadhyay, Mr. L.N. Sharma, and we are awaiting Shri Ashish Chadha, who will be joining in the middle of the session. This session will be chaired by Shri Sunil, who is currently serving as the Additional Director General with India's public service broadcaster, Prasar Bharati, and looks after the international relations, marketing and distribution division of Prasar Bharati at the corporate level. He is an MTech and MBA in finance and has over 3 decades of experience in the field of broadcast engineering. Mr. Sunil has essentially worked with installation of broadcasting projects in India and overseas, covering the domain of high-definition TV studios, digital transmitters, and satellite uplinking earth stations. He has planned and executed the setting up of the DTH platform for the public broadcaster and is responsible for the marketing domains of DTH services of Prasar Bharati called DD Free Dish. He has also served as Secretary General of Broadcast Engineering Society of India. A winner of the ABU Broadcast Engineering Excellence Award for 2018, he has also recently been elected as Vice Chairman for the Technical Bureau of the Asia Pacific Broadcasting Union for the team term 2018-2020. Congratulations, sir, for that. Mr. Sunil is a standing jury for 2018-2020 for judging the international awards of the Asia Pacific Broadcasting Union. Thank you very much, sir, for taking out time and chairing the session for us. A special session because this will be co-chaired. This session will be co-chaired by Flight Lieutenant Rupa Rathore Gaur, retired. She is the head of sales in Prasar Bharati for Doordarshan and All India Radio. A graduate from Lady Shri Ram College for Women, Delhi University. She is among the first few women of India who donned the defense uniform by joining the Indian Air Force in 1993. She has been a keen sports person and was selected for the Indian handball team in 1991. She portrays dynamic leadership through her vast career experience spanning over 21 years as an administrator, marketing and sales, corporate communication, and PR specialist in organizations of repute. An adventurist by nature, she likes to travel and is a poet at heart. Welcome, ma'am, and thank you very much for your invaluable time for chairing this session. On that note, I hand over the session to the chairpersons.
Welcome, delegates, to this session today. Monetization is going to be the trump card in the content industry. The globe is already marveled at the cornucopia of the content available and the standard the OTT players have set for a phenomenal viewing experience. While technologies such as augmented reality, virtual reality, hassle-free streaming, and artificial intelligence are all fine, marketers feel if one thing that is going to keep the OTT providers firm, distinguished, and detectable, then it is the monetization. Lower technology expenses, faster broadband speeds, and frequent innovation have made the video on-demand industry a desirable yet a tricky place to be in. We have our first speaker for the today's session, Ms. Anita Nair, who is seated next to me. Anita Nair is a veteran of the Indian media industry. As CEO, India and Southeast Asia, Havas Media Group, she took on the mandate of expanding the Havas Media Group footprint in the emerging South Asia markets in 2006. Under her leadership, Havas Media Group in India has grown exponentially. It has expanded its offerings as an integrated communications group for traditional, digital, mobile, performance marketing, and out-of-home. The agency has grown 18 times in 13 years. Her 30+ years in the industry have seen her manage a portfolio of brands across sectors, a prominent speaker, moderator, panelist, and judge at all the major events and awards year on year. Her views and opinions are sought by the media. Anita's era of expertise includes media, digital, mobile, entertainment, OOH, and sports with a keen understanding of brand and marketing across the sector. She holds a bachelor's degree in microbiology and has done her post-graduation in advertisement and marketing with a master's in management. Over to Ms. Anita for her presentation.
Thank you so much. I can run it from there.
Yeah, please. This is for you.